Picture this. A startup gets its Snowflake invoice. It is $9,000. Last month it was 3,000. Nobody ran anything new. The work did not grow. The bill just leaked. Here is the good news. 5 quiet leaks drain most Snowflake bills, and all 5 are one setting fixes. For each one, I will show you the anti-pattern, then the fix, then how to find it in your own account. By the end, you will have a weekly routine that keeps the bill honest. Let me show you where the money actually goes. Take a look at any Snowflake bill. It splits into two buckets, compute and storage. Compute is the warehouse running time, that is the big number. Storage is usually small, so almost all your savings come from running engines less or running them smaller, not from the data sitting at rest. Here is the rule of thumb: fix compute first, tidy storage second, chase the big number before the small one. Now, let me reframe how you should think about cost. We just saw where the money goes. Here is the mindset shift. Cost is an engineering metric. A query that scans 30 times more data is not just slow, it is 30 times more expensive. Same answer, 30 times the credits. Treating cost as finance's problem is how teams get the surprise bill. The engineer who watches credits gets trusted with the account. That engineer is you starting today. Let me show you leak number 1. Here is the most common leak. I see a large warehouse, auto-suspend turned off. It sits idle most of the day and it bills the whole time. Think about that. You are paying for a V8 engine to idle in the driveway. Two problems stacked together here. Idle compute is pure waste and oversize means paying double for half used capacity. The bad news, this one is everywhere. The good news, it is the easiest to plug. Let me show you the fix. Here is the one line that plugs leak 1. Alter warehouse, set the size to small, set auto suspend to 60 seconds, set auto resume to true. The intent is simple: start small, size up only when queue time or runtime tells you to, and suspend fast. 60 seconds idle and the engine parks itself. Here is the key: auto resume means there is no downside to suspending, it wakes on the very next query. You save credits and the user never notices. Now leak number 2. Imagine a runaway job at 2 a.m. A bad join, a forgotten warehouse left running over a weekend. With no cap, it just keeps spending. This is leak 2, no spending guardrails, and here is the painful part: you find out at the invoice, not when it happens. By then, the credits are already gone. A guardrail flips that around. It turns a surprise bill into an automatic stop. Let me show you how to build one. Here is your guardrail. Create resource monitor with a credit quota of 1000. Then two triggers. At 80% notify you, at 100% suspend. Then you attach it, alter warehouse, set resource monitor to monthly. Think of it like a budget alarm on a credit card. It warns you at 80% and it cuts the card at 100%. Set this once, sleep better forever. Now leak number 3. Here is a sneaky one. Multi-cluster misuse. Someone cranks max cluster count high for safety or leaves the standard policy spinning clusters eagerly. And here is the catch. You pay for every cluster that spins up, even one that runs briefly. 5 engines firing for a trickle of queries, most of them idle. Multi-cluster exists for real concurrency, hundreds of users at once, not as a default safety blanket. Let me show you the Sane setting. Here is how you payment: alter warehouse, min cluster count 1, max cluster count 3, scaling policy set to economy. Now the intent economy waits a bit before adding clusters. That is cheaper. Standard adds them fast for lower latency. You pay for that speed and the big lever is max. Set it to your real peak concurrency, not an imaginary one you guessed at. 3 is plenty for most teams. Now leak number 4. Here is the leak hiding inside your queries. Select star, no filter on a huge table, or a filter written so badly it defeats pruning. And here is the chain reaction. More bytes scanned means more compute time, which means more credits. For the exact same answer, picture two queries side by side. One reads every micropartition, all red. The other reads a handful, green. A full scan can move orders of magnitude more bytes. Let me show you how to prune it. Here is fix for 3 habits. No new product. Filter on the columns your data is organized by and select only the columns you actually need. Never select star on a big table. Then check the query profile. Look at partition scan. That number is your pruning scorecard. Fewer is cheaper, and cluster only large tables you filter on an odd column. Because clustering itself costs credits, do not cluster everything. Now the last leak. Here is the quiet one. Storage bloat, long time travel retention set everywhere. Abandoned clones, forgotten big tables. Every version and every clone consumes storage even after you have moved on. You are paying for what you forgot. Now, to be fair, this is a smaller leak than compute. But here is the thing. It is basically free to fix. Let me show you the cleanup. Here is fix 5. Match retention to the table. Alter table staging. Set data retention time in days to 1. Staging data does not need 7 days of history. Then do the housekeeping. Drop clones you no longer use. Drop staging tables you have finished with. And keep an eye on it. Watch account usage. Table storage metrics. That view shows you exactly where the bloat is hiding. 5 minutes of cleanup. Real money saved. Now let me give you the audit queries. Here is how you find your own leaks. Do not guess, measure first query. Your top spenders, select warehouse name and sum of credits used from warehouse metering history. Group and order by the credits descending. That ranks every warehouse by spend. Second, your heaviest queries. Order query history by bytes scanned over elapsed time. That surfaces the expensive ones. Then start tuning where the credits actually are, not where you imagine they are. Let me turn this into a weekly habit. Here is the routine that ties it together. Call it the 10-minute weekly cost review. Every Monday, run the metering query. Eyeball the top 3 warehouses and the top 10 queries. Then ask one question: anything new and expensive? If yes, trace it to one of the 5 leaks and fix it that same day. 10 minutes a week that beats a quarterly invoice shock every single time. Let me show you all 5 fixes working at once. Let me make this concrete. Picture a team with one always on large warehouse. No monitors, dashboards running select star. Every leak we covered all at once. Now watch the fixes land. Split it into right side warehouses that auto-suspend, add a resource monitor, prune the dashboard queries, and here is the result. Same workloads, same dashboards, a fraction of the credits. The bill follows the work. Now, but a quick warning before you go wild. Here is the trade-off nobody mentions. Do not over-optimize. Spend your tuning effort where the credits are. The top few warehouses and queries. Shaving a query that costs pennies. That is not worth an engineer's whole afternoon. Optimize the bill, not your ego. Remember the pattern: 80% of your spend hides in just a few places. Go there. Ignore the rest. Let me hand you the checklist. Here is your one-page checklist. Screenshot this slide 1. Right size and auto-suspend your warehouses. 2. Add resource monitors. 3. Set sane multi-cluster bounds. 4. Prune and filter the heavy queries. 5. Tune retention and clean up storage. Then the habit that holds it all. Run the weekly metering review and always fix where the credits actually are. Let me wrap this up. So that is the whole playbook. 5 fixes that routinely turn a scary bill into a predictable one. And you keep your performance the entire time. Right size, guardrails, sane scaling, prune your queries, clean your storage. That is it. If you want to go deeper, the full Snowflake cost optimization course is linked below. Subscribe for the architecture and pipeline deep dives. And tell me what is your biggest leak. Drop it in the comments.